to be the objectives of this course. In this particular course, the following lessons would be taken care of. We will do the classification of solids, and we will classify solids into amorphous and crystalline solids. Then we will further classify the crystalline solids on the basis of the forces of attraction between the constituent particles and the kind of constituent particles present. The crystalline solids have a definite pattern, so we are going to study that pattern in this course. We will study the unit cell, the smallest particle of any solid, or the smallest arrangement of any solid in 2-dimensional and 3-dimensional lattices. Then we will also do certain calculations so as to give us the dimensions of a unit cell. Then how the constituent particles they are arranged in a particular crystal, that is packing in solids, that we will do in 2 different sections. Then we will also do the defects in crystal in which certain constituent particles they move away from their location. And lastly, we will do the electrical and magnetic properties of solids. So in this particular course, we are going to discuss the entire properties of solids. Let's go on to the first lesson of this course, that is characteristics and classification of solids. Now, when we're talking of solids, you know that anything what you are looking in your surroundings which have a fixed shape or a rigid shape, they all are solids. For example, the chair you're sitting on, the table you're working on, there are balls, there are pencils, there are sharpeners, erasers, pens, all these they come under solids. So we can say that any solid has a definite shape and volume. Now, when we are also talking of solids, the molecules of solids are very, very closely packed. They are so closely packed that there is no intermolecular spaces between them, but because of their close packing, they have very high intermolecular forces of attraction. That is the reason, because of their fixed volume and fixed shape, we say that the solids, they are rigid. Now, rigidity is due to what? It is due to the reason that the solid particles, they cannot move. They can only oscillate about their mean positions, as a result of which they have a rigid shape. Now, most solids, they become liquids when heated. Why are they becoming liquids over here? That is because on heating, the kinetic energy of the molecules, that is going to increase. When the temperature increases, the movement will increase and they will go far apart from each other. That is the reason why they are being converted into liquids. Now, this process of conversion of solids into liquids, this is known as melting. Right? Now, what we are saying that we were also discussing about the densities. The densities of the solid, that is greater than that of the liquids. Why? Because density we know that is equal to mass upon volume. Mass of the solid is fixed and the volume of the solid, it is small, which results in higher density of the solids as compared to that of liquids and gases. Classification of solids is done on the basis of arrangement of the constituent particles. These constituent particles may be atoms, ions, or molecules. Then, on the arrangement of constituent particles, we are classifying the solids into crystalline solids and amorphous solids. When we're talking of crystalline solids, we say that the constituent particles are arranged in a definite geometric pattern, which means that each atom will have a definite position in crystalline solids. Whereas, when we are talking of amorphous solids, the particles are all randomly arranged. They can be placed anywhere in a solid. So the amorphous solids do not have a fixed or regular arrangement. When we're talking of crystalline solids, the regular arrangement of the crystalline solids, that goes for a larger area of the crystal, which means that when we are moving along a crystal, it has same kind of arrangement over a larger area. So this is known as what? It is known as long range order. On the other hand, in the amorphous solid, every now and then, after every small intervals, the arrangement that is going to change. So that is why we say that amorphous solids, they have a short range order. Then crystalline solids, there are many examples. All the metals, they come under the crystalline solids, like we have copper, we have silver, we have iron, and compounds like we have NaCl, potassium nitrate, zinc sulfide, quartz, all these come under crystalline solids. And amorphous solid is glass, rubber, plastic, etc. Then what do we understand by pseudo-solids or supercooled liquids? Amorphous solids, they are known as pseudo-solids. Pseudo means false, right? So what are we saying over here is that they are false solids. They are generally formed by supercooling the liquids, and glass is a very good example of this. When we're talking of glass, you must have seen the glass panes of very old buildings in which the glass panes, they are thicker from the bottom and they are thinner at the top. That is because over the time, glass that starts melting, and as a result of which it keeps flowing to the bottom due to the forces of attraction of gravity. Now, because of this, it can be said that glass, it is a supercooled liquid and it is not a true solid. Then there's another very important difference between the between the crystalline and the amorphous solids. The crystalline solids, they are anisotropic. What do you understand by anisotropic? As you can see in the figure over here, what are we looking at? We are looking at two kind of particles, one which is blue and the other one which is red. So there is alternate blue and red particles present. The first row is of blue and the second row is of red. Okay. When we are moving along position A and B, you can see that only blue particles are aligned in this particular area. But when we are moving from C to D, in this there is one red particle, then there is one blue particle, then again there is one red particle. So there is alternate positions given to two different kind of particles. When we are moving from A and B and we are suppose calculating any physical property, like we are calculating refractive index. So if we are calculating the refractive index from A to B, in this particular A to B, the refractive index is going to be different than if we are traveling from C to D. Such substances which have different properties in different directions, they are said to be anisotropic. So all crystalline substances, they are going to be anisotropic. And what do we understand by isotropic? When all the properties, they are same in all directions, such substances are said to be isotropic. For example, we have amorphous solids. All amorphous solids, they have isotropic, and even the liquids and the gases, they are said to be isotropic. So this is one major difference between crystalline and amorphous solids. Then we have now studied the entire crystalline and amorphous solids. Let's just arrange the points in matter of differences between the two. When we are looking at crystalline solids, we say that they have a definite shape. This we have already studied the first point which we studied about crystalline solids. Whereas amorphous solids, they are going to have an irregular shape. Then when we're talking of crystalline solids, the crystalline solids, they have long range order. So what is long range order? We have just studied that they have the same kind of arrangement over a longer area. Whereas the amorphous solids, they have short range order in which the arrangement will keep on changing after small intervals. Then there's another new point which comes over here, that is the crystalline solids, they have a sharp melting point, which means that they will immediately change into liquid at one particular temperature. Whereas the amorphous solids, they do not have a sharp melting point. That is, they keep on melting over a range of temperature. So they will become soft, and henceforth they will melt. So we cannot have a definite, we cannot say that, this is the melting point of any particular solid. Then the crystalline solids, they have a clean cleavage. When we're cutting crystalline solids with help of a knife, they will have absolutely a clean cleavage. Maybe something, you can see they will have a clean cleavage, something like this, right? Whereas the amorphous solids, they do not have a clean cleavage. They will have an irregular cleavage of this type. Then the crystalline solids, they are anisotropic in nature. This we have just discussed. And amorphous solids are isotropic in nature, right? Crystalline solids are true solids. Okay. Whereas the amorphous solids, as we just discussed, they are the pseudo solids. So with this, we finish our first lesson of the first course of class 12. Now in the second lesson, we are going to discuss the crystalline solids in detail. Amorphous solids we are not going to discuss any further, but crystalline solids is an important discussion of this entire chapter.